Okay, today we're going to be looking at algebra. Specifically, we're going to be looking at solving equations. We're going to have equations where x is on both sides, and we're going to use an analogy where we treat equations like scales that are in balance. So, when we're doing some manipulation of equations, anything you do to the equation must keep it in balance. Okay, so we'll look at some examples of this idea. Since we're using an analogy of scales, let's draw some scales with some items on. Okay, so these scales are currently in balance. We have 3 squares and 3 ones on the left side, and 2 squares and 6 ones on the right side. Now the things that we're allowed to do must keep the equation or the scales in balance. So you could take off the same amount of items from both sides. Plus 7 on the right side there, I added another 1. Okay, so what could we do? Well, if we draw this out again, so we've got the 3 boxes and the 3 ones, and then the 2 boxes and the 7 ones. What's something we could do to keep it in balance? Well, what we could do is we could take away 3 ones from both sides. This would keep it in balance. Because if you take away the same amount from both sides, if it was in balance, it's still in balance. Okay, so the scales are still in balance, that's allowed. What else could I do? Well, if I get to the same stage that we were at just then, let me just go forward a little bit. Oh, no, not that far forward. Hold on. Just to here. Okay, so there we go. Nope, there we go. Okay, so sorry about that. We're at the same stage we are now. I've just copied the drawing down. So we have 3 boxes on the left-hand side, 2 boxes, and now we have 4 plus 1s on the right-hand side. So what can we do now? Well, why don't we take away 2 boxes from both sides. This will keep it in balance because we're taking away the same thing from both sides. Okay, so now we have the scales are still in balance, and what you can see is that our box is the same as 4 ones. It's the same as 4 plus 1s. Our box is the same as 4 plus 1s because that's what the scales says. Okay? So what we're going to do is we could call this box an X rather than a box. Okay? So if we were to write down the situation that we have in algebra, then the first scale we have 3 x's and 3 plus 1s, and on the right hand side we have 2 x's and 7 plus 1s. Okay? So because they are scales in balance, we can say they are the same, so they're equal. Okay? So after that, what we did was we took away 3 from both sides. So the next scale, the second scales there, we have 3 x's on the left hand side, and these are the same as 2 x's and plus 4. Then if we look at the bottom set of scales, we have an x on its own on the left hand side is the same as 4. So if we go back, so we have x is equal to 4. So that's solving an equation with x on both sides. It seems very simple using scales, and the scales is just the same as the algebra. Okay, we're going to have a look at another example now. So we're going to deal with negatives in this particular example, and with division as well. So on the previous video we just took away things from both sides. Now we're going to look at a slightly more complicated example. So rather than write boxes, I'm just going to write x's now. So here we have the situation. We have 5 x's and 2 minus 1s on the left hand side, and we have 2 x's and plus 4 1s, so plus 4 on the right. Okay, so if I repeat the drawing there, okay, what could I do? Well, something I could do, instead of taking away things from both sides, I could add the same thing to both sides. So why don't I add 2 plus 1s to the left side and 2 plus 1s to the right hand side? So I have just added 2 to both sides. Okay? I hope you agree that the scales are still in balance because I've added the same thing to both sides. So if you notice on the left-hand side, we've got a +1 and a -1. And a +1 and a -1, they cancel to make 0. And we have that happen twice. So those cancel, so we have just x's now on the left-hand side. Okay? I'm going to write down the equations that we have manipulated using algebra rather than sets of scales. So on the first line we have, or maybe you could do this yourself, pause it, just check you get it right. So we have 5x minus 2 is the same as 2x plus 4. Then what do we do to both sides? Well, we added 2 to both sides. When we added 2, we got left with the situation 5x is equal to 2x plus 6. Okay? So that's what the second set of scales represents. 5x is the same as 2x plus 6. Okay, so what can we do now? Or maybe you have an idea of what we're going to do next. Well, why don't I draw the situation again? So there's the situation drawn again. And what can I do now? Well, let's get rid of what cancelled. These cancelled. Why don't I take away 2 x's from both sides? So if I do that, I take away those 2 x's and those 2 x's. So now it's still in balance because it needs to stay in balance. I could rub these out, and what I'm left with is, well, if I take 2x from both sides in the equation, you can see on the scales it's 3 x's on the left-hand side is the same as 6. Okay, now the next step is using algebra and scales is a bit trickier to explain, but I'm going to do my best. So if we have 3 x's on the left-hand side and plus 6 on the right-hand side, then something I can do is I can group them. I can make 3 equal groups. And you can see, looking at the 3 equal groups, that 1x must be the same as plus 2. So an x is the same as 2 1s, okay? So this is putting it into 3 equal groups. Putting it into 3 equal groups using a mathematical operation is the same as dividing by 3. So we can divide by 3 on both sides. Putting it into 3 equal groups, we can divide by 3 on both sides. When we divide it by 3 into both sides, well, 3x divided by 3 is just x. And 6 divided by 3, well, that's 6 over 3, which is the same as 2. Okay? So we have 1x, and x is the same as 2. So this is how to deal with negative numbers, and how to deal with division using the scales. Okay, I've just gone into a quieter room, so hopefully this sounds a bit better now. We're going to look at one more example, possibly a slightly more difficult example. We have this situation here. Okay, so you can see that we have minus 2 and minus 2x on the left-hand side. On the right-hand side, we have plus 2 and plus 3x. So I've written minus 2 minus 2x is the same as 3x plus 2. Okay, so what we can do, well, maybe you can think about the first operation you might do. The suggested operation is to, say, add 2 x's to both sides. Okay, this is allowed because you're adding the same thing to both sides. If we draw that situation again, hopefully if I go forward. So there's the situation again, and we can add 2x onto the right-hand side, which means we have to add 2 x's onto the left-hand side. Now if you notice that the minus x and the plus x, they cancel out. So we're left with no x's on the left-hand side. We could write this in algebra. So if we add the 2 x's, we get rid of that minus 2x, so we get minus 2 is the same as 5x now plus 2. So what did I do? Well, I added 2x. These arrows signal to the reader the operation you just did. Okay, the next level using scales, what could we do? Well, maybe one thing, this isn't necessarily the right thing to do, but someone might do it. You could say add 2 to both sides. Again, if I go forward, oh, not that far. Not that far again. There we go. Didn't work. Okay, anyway, we'll draw that out again. So, cancel, cancel. Now we're going to add our 2 to both sides. So add 2. Still in balance. Notice how these now cancel on the left-hand side. So what am I left with on the left-hand side? Well, we're not really left with anything. Okay? If we're going to write this situation, we could write it as an equation. So what have we done? We've added 2 to both sides. The right-hand side becomes 5x plus 4. You can see that from the scales. And the left-hand side, well, there's nothing there, so you write 0. Okay? So what might I do now? Well, maybe you want to get x's on their own on one side. That's kind of the goal here. So to get x on its own on one side, what we could do is we could, say, subtract or take away 4 from both sides. So if we take away 4 from both sides, on the left-hand side, you'll get negative 4. And on the right-hand side, you'll get 5x. Okay? So taking away 4 from both sides. Check you're happy with that idea. And what do we do now? What do we do now? Well, maybe I'll just draw that set of scales that we've got. If I go forward a bit. Okay. A bit further. So we were here and we take away 4. So we add 4 negative 1s to both sides. That's the same as taking away 4. And they all cancel, cancel, cancel. So we are left with 5x equals negative 4. Okay, so now we've got a situation where we need to find the value of x. So we've got 5 x's, so why don't we try grouping into 5? So that's not quite clear what to do. I just need to get forward to where we just were. Okay, so instead of drawing them like that, what I'm going to draw is I'm going to put 5 x's in a row. So I've put them into 5 groups, sort of. Okay. But we know that grouping into 5 equal groups is the same as dividing by 5. So why don't I just divide by 5? So if I divide by 5 on the right-hand side, I get x on its own, which is what we want. And if I divide by 5 on the right-hand side, well, I just get minus 4 divided by 5. Minus 4 over 5, or minus 4/5. That's the value of x. We have now solved the equation because we have x on its own on one side. Okay, we'll do lots of practice of this in lessons. Hopefully you followed that. The key messages are, I suppose, that solving equations is to find x on its own on one side. The things that you're allowed to do, well, the only things that you're allowed to do must keep the scales in balance. So you must do the same thing to both sides. Okay, thank you for watching.